Thank you all for coming to the session. I'm very excited to be here. So it took me 3 hours last night to wait for my 15-minute flight, so I would like to apologize in advance for any bloopers that I might make. I got here at 3 in the morning. But let's get started. So the session is going to be about transformations through automation. Just wanted to quickly go through the agenda. Basically, I'll quickly cover the definition of DevOps. I'm sure everybody here knows what it is, but there are so many definitions, and I would just like to set the context. Then we'll go through the steps that will actually take us to the true state of DevOps. And then I wanted to show what, in my opinion, is the target state and where we want to be. So briefly about myself. My name is Tanya Kravtsov. I'm heading up the automation and continuous delivery practice at ROKITT. ROKITT is actually only a few months old company. So I think my professional and personal life can best be described as a series of transformations. I started out working at big financial companies, then I moved to a product development company, and now I'm at a startup. And also I started working as a developer and moved into testing. Then I moved into automation and realized that this is where my passion lies. Exactly a year ago at this conference is where I got an idea to start a meetup group which is called DevOps QA of New Jersey. And the reason was because I wanted to hear more and talk more about DevOps, and there was nothing in New Jersey that covered that. So we now have 200 plus members, and we meet on a regular basis, and it's very exciting. So as a tester, I've been developing and managing automation for many years. And at some point, I realized that even though testing is automated, it's not enough. There are still a lot of processes before and after and during which are manual, which kind of make the whole automation lose value. And that's when I started realizing that there is a much bigger world out there. There is not just test automation, there is process automation. And basically, this is why I'm here. I went through the several transformation initiatives in my previous company, and now as part of our startup, we're actually working with different companies and help them to transform. And just wanted to share the experience of how you can get from being entirely manual or having some automated processes to the point where you truly can deploy 10 times or 3,000 times a day, as Jenkins was just telling us. Lastly, I used to be a competitive ballroom dancer. Now I'm a mom and working 24/7 almost. So yes, transformation, I think, is part of our lives, and that's what we're going to talk about. So there are many definitions of DevOps. Some of them I really like. One of my favorite ones is the one that Jenkins just went through, talking about 3 ways. However, I think this one summarizes it the best. It was coined by John Vives, and it's called CAMS. And then L for lean was added later on. But basically, it talks about 5 components of DevOps, right? Culture is the #1 component. If you don't have a culture in your company which is ready to accept the changes, it's very difficult to get started. You might start automating and putting things in, but if they don't get accepted, it's going to stay with one group or with one person. Once you have the acceptance, that's when you start automating, right? And automation is the essential component of DevOps. You automate every manual process that you can find, and you make sure that whatever you automate doesn't break because of something else that's interrupting it. Lean is, I think in Jenkins' book, he mentions that DevOps is a lean for IT. It basically helps you to identify bottlenecks and get rid of them. And this is what lean is all about. Once you have your automation in place, it's very important to continue monitoring it and measuring it, right? And this is what M stands for. And the last important component is sharing. This is what all of us are doing here. You're talking to each other. Me presenting here, this is us sharing what we learned about DevOps, and that's how DevOps gets spread, and that's how more companies get started. So this is all about what DevOps is, but basically, how do we get there? That's the most important question. Step #1 in starting the journey is identifying the bottlenecks. And again, I want to refer to the Phoenix Project book, which I really like, where Jenkins made the statement that any improvement made anywhere besides the bottleneck is an illusion. And what it means is if you improve something where you don't have a bottleneck, it might actually speed up your process, but if the bottleneck comes afterwards, it's only going to make it worse. If you improve something after the bottleneck, then again, it's not really going to help you. So we need to identify what those wastes are, what those bottlenecks are, and we need to figure out how to address them. So let me know if any of those look familiar to you. You have your, as an automation tester, right? We very often run tests, we find bugs, but then developer says it's not a bug, it works on my machine. It could be an environment issue, it could be a data issue, but as long as we have this, we do not have true transparency of how a product works. Almost every company right now is going agile. And it's great, everybody's going through the sprints, developers are committing to their points, but what we find very often is because of those commitments, there is no time for anything else. There is no time for those 20% to clean up your backlog, to fix the bugs, and to put the processes in that actually can help to speed up the delivery. And finally, there is always few people in the company that want to change things, but then there is probably 90% of people who are perfectly happy with the way things are, and they don't want to accept those changes. So in my opinion, these are some of the major bottlenecks. I'm sure you have more examples of your own, but I would like to concentrate on those. So some things that can cause the bottlenecks are inconsistent environments, your test cycle, which takes a long time and cannot provide you quick feedback, and manual processes. So now that you identify the bottlenecks, what can we do next? Again, most companies have this. Everybody versions their code, but not everybody knows that everything should be stored in version management system. So while the code is stored in Git or SVN, you also have your tests, you have your infrastructure code, you have your requirements, which are all stored in separate locations, so very often they're actually stored in Excel files or Word documents on local hard drives. As long as that happens, there is no consistency, there is no single point of truth, and you cannot link your code to your environment, to your tests at a single point in time. So this is number one before you automate anything else. Just make sure that you can trace everything back to a single location. Almost in every slide, I have examples of the tools a lot of you might be using or might be familiar with. But this is some of the tools that I worked with in previous companies and right now. Also, once you have your code and your scripts and requirements, it's also important to store your release and deployment artifacts in the version management system. Because if for some reason something happens and you have to go back, you have to have an ability to do that rollback. Once you have that, then you should automate the build. I think this is one of the points that most companies already do. I have rarely seen manual builds in the past couple of years, but what still often is there is that you have to push the button to run that build. Even though the build process itself is automated, it's not integrated with any continuous integration. So it's very important, one, to automate the build, and then have that build as part of your development process. So as soon as the developer pushes the code, that build gets triggered automatically. It's not always possible because sometimes builds run for hours, which is the first thing to address, right? So if your build takes a couple of hours, there's probably some way you can improve it. So once you get your build to under an hour, you can try to do it after every commit, or at least do it after every several commits, and trigger it automatically. And if the build is broken, the developer who broke it has to fix it until the code goes to testing or anything else. So next step is why all of us are here, right? It's continuous integration, Jenkins. Very important step in getting to the DevOps is setting up the continuous integration server. Jenkins can bring all those pieces together. You have your version management, you have your build automation. So just to get started, you can start by integrating that. Once you set up Jenkins, you integrate it with your version control, you integrate it with your automated build scripts, and all of a sudden, you're already on your way to DevOps. You're building after every commit. You're checking out code as soon as developer checks in. and you do your builds. And if the build breaks, you send an email to developers. So this is probably like 50% of your continuous integration process. Once you have your build automated, it's good to know that the build works, but then there are other things that might break. Right? So the next step is to introduce unit testing. And this is actually surprisingly, even though right now it seems like everybody's doing testing, unit testing is something that either done manually or very often not done at all. And I think, again, it goes back to the whole Agile delivery. We're in such a hurry to deliver code that we don't have time to write the tests. Right? And that, I think, is an issue because we end up paying for it later on. So many of you probably have already seen the testing pyramid. And this basically says that majority of your tests should be unit tests. The reason being that even though when you think test automation, usually you think about UI automation, this is the worst thing that you can possibly automate, right? UI constantly changes, it's not stable, it varies based on your screen resolutions, it's different for mobile, it's different for web. However, when you test on the unit level, it's stable and it will give you consistent result all the time. So definitely create unit tests. Here I list some of the best practices. I mean, unit tests have to be short and independent. They should only fail when a bug is introduced, and we need to know the reason why the test fails. Right? So even though unit testing seems self-explanatory, there is a whole art to it, and it's worth learning. And then, of course, there is test-driven development, which is, again, something that's very popular right now. But basically what it means is that you need to write tests before you write the code. So first you create a test that you need to do as part of your application. You run it, it breaks, and then you write the code that fixes that test. And this way you can make sure that every single possible scenario is covered. Of course, it doesn't eliminate the need for API layer testing and GUI level testing, but I think it's going to bring your product to a whole different level. And now, because these unit tests are small and fast, you can run them after every build through Jenkins or through any other automated process. And you can make sure that not only your build works, but also your most important functionality works. And if it breaks again, you can link it back to the developer who wrote the code. So now that we have the build and the unit test, we can introduce the static analysis and quality metrics. So there are a lot of different varieties of static analysis. There are tools like find bug and PMD that basically validate that your code is coded correctly. There are tools that detect memory leaks. There are tools that detect security vulnerabilities. All of them have plugins into Jenkins. So basically, every time somebody checks in the code, those tools run and they give you a report. And the best thing about them is that you know the difference. So one reason that I've seen why companies don't want to get started with these tools is because your product has been around for many years. And when you run those static analysis for the first time, it returns you thousands of issues, a lot of them high severity, right? So what are you going to do with that? What we've done previously is that you let it run, you get those 1,000 issues, and you make that your baseline, right? So next time you run, if you get 1,001, you fix that one. If you have time later on and you finally have a chance to go to that 20% of refactoring, cleaning up the backlog, then you go back to those 1,000. But don't let the huge report discourage you, right? Just take whatever is there as a baseline and move forward. Also, there is code coverage analysis. So for that, of course, you do need unit testing. But once you have your unit testing, you want to start tracking how much of the code is actually being tested. How many things did you miss, right? So you can integrate code coverage analysis also as part of Jenkins. And every time you check in, it will tell you what your current coverage is, and it will let you know if you need to add any more unit tests. So far, all the things we have described can actually be used and done on the development side, right? Even though, I'm primarily working in the testing, I feel that testing it should not be associated with the QA team. It should definitely start with the development. So all of this unit testing, static analysis, code coverage, this is something developers actually should care about, and I think a lot of them do. But again, I think because of all this deliverables and pressure of the time, there is no time to think about it. But once you start doing this, you will see how it actually simplifies your life. So this is something that's not actually normally practiced, but I found it extremely useful in all the transformations that we've done. We mentioned before that it only works on my machine, bottleneck. And the reason that usually happens is because there are some issues with the environment. So you have everything automated, you run your tests overnight, and then after the first test, everything fails because your database server is down, or because you ran out of your disk space on one of your machines. Right? And basically you wasted your whole regression cycle because of one simple environment problem. So one thing to do, and this is another place where Jenkins can come in very useful, is you can introduce a very small test that's going to run throughout the day. It can run after every commit, it can run every hour, that basically validates that your environment is ready for testing. Right? And this can include validation of your application service, web service. It can check database listeners. It can verify that you still have RAM available, disk space available. It's actually a bunch of shell scripts that you can write. There are tools that out there like WhatsApp Gold that can also help with that. And if you find those issues, you have several ways to deal with that. One, you can just send an email to your system administrators and let them know that there is an issue, please fix it. Another one, you can actually write a script that's going to reboot your servers, that's going to restart the database, and so forth. So it's different levels of how you can address it. But even if you send a simple mail, it actually might prevent you from wasting that nightly regression cycle that you would have otherwise done. Another step to the environment test is the product readiness test. That one I think we're more familiar with. We all do production checkouts, right? We also want to make sure that once we go to production, it's still up and running. But nobody really thinks of it as part of your development and test cycle. Because again, if somebody checked in the code and the build worked, but somehow it completely brought down your application, you might not find out about it until you run your GUI tests, which takes 8 hours. So instead of that, again, on a regular basis, after every commit, just run a small smoke test which just checks the main pages of your application, make sure that it's up and running. And then you can go into your thousands test regression suite. So now that we have the build automated, unit tests automated, we know that the environment is ready, this is when we're ready to start running our automated regression. And again, traditionally, regression testing is done as part of this huge QA cycle, which very often happens once a month. It is not a good idea. Regression is basically confirming that whatever you worked in your application yesterday is still working today. So if your developers committed something, it means that you should verify that everything that worked before still works. Most of the time, you're not able to do it after every commit because application is large. GUI tests take a long time to run, so you cannot possibly run through them in 15 minutes or even in an hour. But overnight is doable. I mean, I've been in a company where regression ran for 6 days when I got there. So there are different techniques you can use to reduce that. One, of course, is you can start running in parallel, right? So you can throw hardware at it or virtual machines, which is great, but there is a small caveat to it, because the more tests you run, the more tests you have to analyze, right? So even if you're able to get through your 10,000 tests in a night, how are you going to look at the results, right? So if you want to run something every night or on a regular basis, you need to reduce the scope of testing, and you need to run what's important. Also, a very important piece is the web services testing. So we run the GUI, but the more you can do on your API levels, again, it speeds up the execution, and you can cover more of the application by doing that. If you can do both, and you can identify if the issue happens on the API layer or on the UI layer, that's even better, right? Because that will speed up developers' analysis time. The data management is a very important piece. So I've seen great automation suites in a steady environment which still don't run because there is no test data. If you have test data processes done manually, then your whole DevOps cycle is broken, right? You cannot have a tester sit down and query databases and write emails to somebody and ask them to make a copy of the production data every time they need to run the test. So that process has to be automated. So there are tools out there. You can write your queries yourself, but basically the data retrieval, generation, and cleanup has to be part of your automated cycle. Finally, if you have a very large automation suite, you have to be selective about what you test. There are different techniques like pairwise testing. Also, a very, very simple solution that almost nobody uses is tagging your tests, right? So just like you label your emails in Gmail, you can label your tests. So next time when somebody modifies a piece of your product, you can just search for that component and say, just run the tests which are impacted by that. Something very simple to do, but not usually practiced. So this probably, again, everybody knows is an important part of DevOps. It's probably one of the most difficult pieces to automate, at least from my experience, is actually automating your environment configuration and deployment. And so the idea is that you want to have your consistent environment every time you run a test. So in an ideal world, before you start your testing, you spin up your VMs using the infrastructure code that you created using tools like Chef, Puppet, and Ansible. You use either Docker or Vagrant to create your virtual environment. And after you run the tests, you bring it down, and then next time you start from a fresh environment. I mean, this is where I think everybody wants to be, but in rare cases, I have seen somebody truly get there, but I think it's definitely worth getting on that road, at least starting from writing the scripts for your infrastructure. Because even if that doesn't work in conjunction with everything else, it creates a perfect document of what your environment looks like. And it speeds up the time that developers otherwise would have spent requesting for a new test environment or development environment. And finally, once we have all the testing running in a stable environment with automated test data, we get the results, right? The reason why we test our application is to find out if it's good to go or no go to production. I mean, this is pretty much the only reason why we have to go through all those things of build and unit test and regression, is to make that decision and be comfortable with it. And in order to make that decision, we need to understand our results. And again, what I've seen in a lot of cases is that majority of time is spent on creating those automation suites, on writing the test cases, on writing the release notes, and very little time is spent on actually reporting. And what is it that you send to developers? What information do we put in our bugs? And how do we let developers know exactly what failed, so when they start debugging it, then can actually debug it quickly and not spend a whole week trying to find what happened. So one is consolidated report, right? We're testing many, many different platforms now. We have a huge variety of browsers. We have iOS and Android platforms. We have desktop versions of our applications. And very often, we're actually still testing the same product. We're also testing on different layers. We're testing on GUI layer, on API layer, on data layer. And every single test produces a different report. So what normally happens is that your developers start getting test results from database testing, from mobile testing team, from manual testing team, from automation testing team, and then somehow you need to reconcile and figure out what really happened. And maybe all the bugs reported by all these different teams is one single bug. Right? So the idea is to consolidate results across all those tools and technologies into a single report, which then just tells you your product is good to go. Right? And this is an art in itself, but it is possible. And we have done it, but basically the idea is that you need to create a standard log, and you need to make sure that all the tools write your results into the same format. And once you have that same format, then you can filter it, you can do different graphs, and you can really see what your state of testing is. also is the next step. I mean, one thing is to report your pass and fails. I mean, I think most of the tools are doing a pretty good job with it. Another step is to actually analyze what failed and why it failed. So the best thing that testers can do, and this is something that, when we teach automation testing, I think this is an essential part of it, is to understand that this 1,000 failures that you see as fails is really one bug. So again, tagging of the test helps a lot because you can see that, okay, the same functionality failed. Also, being able to filter your reports by machine that they're running, because maybe if 100 tests failed on the same machine, that might tell you something, right? That there is a problem with that machine, and it's not because there is an issue with the product. So being able to filter by every possible parameter that can cause a failure, like which database does it run against, which app server does it run against, all of those things can actually help you to not only send the report, but to analyze those reports. So by the time you log a bug, you can actually say, okay, this is the bug which happened on all of these machines, which have the following parameters, and developers can right away say, okay, this happened because, I don't know, password expired on our mainframe. And they wouldn't spend weeks or days or even hours trying to identify what the problem is. Also, the means of reporting is very important. I mean, we've seen emails, Excel files, tools like Quality Center and Jira. I think the most important thing about reporting is that you need to report fast, right? So as soon as there is no reason to wait for the whole test suite to finish to let somebody know that there is a critical bug in the system. So Jenkins actually does a great job with that because it has like email notifications incorporated with it, right? So if something happens and you analyze the results, you can right away send emails to whoever is responsible and let them know that something failed. And then, of course, Jenkins has its own reporting dashboard, plus it's good to have a dashboard where you can filter through the results. I think visualization is also very important. There are a lot of great tools right now that helps you visualize your data. And your results is basically data, right? So if you can visualize it in the right way and present it to the developers and your management, that it can make their job of making their decisions a lot easier. So finally, the target state. And basically, I think we covered all of this. So the first part is all of your artifacts are in your version control system. Once you have everything centralized, you have your continuous integration framework using a tool like Jenkins. You have your taste data retrieved automatically. You have your test environment set up automatically. Once you have all of those components, you can have your automation test framework that runs your automation test. And finally, you have your reporting dashboard that gives you that green light or red light. And ideally, it runs against a staging environment, which is the same as production. Sometimes it's a scaled-down version of production. But the main thing that I'm trying to show with this picture is that it's continuous, right? There is no manual processes here. This is what DevOps is all about. I mean, it's basically trying to help us get to the state where we have no bottlenecks. And while it might seem impossible, I mean, I think we can come very, very close to that, and we can make something like this possible. So what's the conclusion, right? I mean, I think a lot of people discuss what DevOps is. I've seen a lot of articles on the internet, people arguing what it is and what it isn't. I think the main question we should ask is, what does it do for us? What can it do for our organization? And how do we get there? So things that I described are probably don't even cover large portion of what DevOps is about. But from my experience, I think it can truly get us there. So I mentioned a lot of tools in those slides. Most of them you probably heard about. Some of them might be new. One tool that wasn't there is you, right? Because those tools without us are not going to help anybody. Somebody needs to start looking at them, learning them, and implementing them. So the conclusion is take action. Start learning those tools, start writing those scripts, go back to your management or go back to your employees and let them know that that's it. We're starting on our DevOps journey. These are the tools out there. Let's do proof of concepts. Let's try to automate our environment. Let's try to automate our testing. And a year from now, maybe you'll come to this conference and you'll talk about your experience of how you were able to get to your target state. And I think this is it. If you have any questions, please feel free to ask.